All right, the section that we're talking about here is section 3.6 called inductive reasoning. And when we look at reasoning in geometry, we have two types of reasoning we work with. We work with deductive reasoning, which is when we use facts and accepted statements. And when we use deductive reasoning, we find out that something must be true. This is the type of reasoning we use for proof. Now, inductive reasoning is when we use patterns and experience to make conclusions. This is used a lot in the real world. For example, if every day a student brought me a pie, Monday he brought me a pie, Tuesday he brought me a pie, Wednesday he brought me a pie, Thursday I would open my door expecting this student to bring me a pie. But that doesn't mean it's always true. So with inductive reasoning, we have something that we say is probably true, but it's not always true when we make a conclusion using inductive reasoning, because this is using patterns. Now, if we do some patterns mathematically, some examples here of inductive reasoning, we might say, all right, we have a pattern here that we need to figure out with our numbers. And we say 4, 7, 10, 13, 16, blank. Well, we look here and we say, well, from here to here we added 3. And to go from here to here we added 3. And to go from here to here we added 3. And here we added 3. So I'm going to assume that is going to continue and add 3 and say my next number is 19. Now that one's fairly simple. We can get a little bit tougher. We look at this one, 1, 5, 11, 19, 29. Well, let's try those differences here and see if it's an addition problem. Let's see, here we added 4. And here, the difference there is 6. That's not the same. On here, the difference is 8. And here, the difference is 10. Oh boy, but wait, I think I see a pattern here. Since this goes up by 2 each time, I'm going to assume that I'm going to add 12 here. All right, to make my next number 41. Take a look at this next one. 3, 6, 5, 10, 9, 18, 17, 34. Now some people might say, well, we added 3 here, and we subtracted 1 here, and then we added 5, then subtracted 1, then added 9, then subtracted 1, then added 17, then subtracted 1 maybe? What I see here is that this is multiplied by 2, and then we subtracted 1, and we multiplied by 2 again, subtract 1, multiply by 2, subtract 1, multiply by 2. I'm going to keep this pattern going and say it's going to be subtract 1, so my answer would be 33. Okay, and that's how we do some problems with inductive reasoning.